Hi, in this video we are going to learn how can we use balanced equation in stoichiometry. First of all, we are going to find a chemical balanced equation. By this chemical balanced equation, we are going to use this equation to calculate the stoichiometry of the compounds. First of all, what is the meaning of stoichiometry? Stoichiometry is about studying the relationship of volumes and moles of the reactants and products at the equations. So here we have two reactants and we have two products. So how can we find the stoichiometry of the following compounds? So first of all, we have two types of stoichiometry, from mole to mole or from mass to mass. We are going to learn from mole to mole stoichiometry relationship. So let's find out together how can we solve this type of questions. Calculate the moles of potassium iodide that produced from the reaction of 2.5 moles of lead iodide. So how can we solve this type of questions? Let's find out together. First of all, we are going to write moles relationship. Here at the question, we need to calculate the moles of what? Of potassium iodide that produced from 2.5 moles of lead iodide. So we have two compounds. Let's go to the chemical equation and find out the moles of each one of them. How can the chemical equation help us? We are going to use the numbers that exist before each compound, and let's use these coefficients as the number of moles. So how many moles of lead iodide? We have only one. How many moles of potassium iodide? We have only two. How many moles of lead nitrate? We have only one. So let's use this number from the balanced equation to find out the stoichiometry. So first we are going to do the moles relationship. So we need to calculate what the moles of potassium iodide. So let's write the moles of potassium iodide at the equation, which is 2 moles of potassium iodide over how many moles of lead iodide we have? We have only one. So the moles relationship here is 2 to 1. Lead iodide. So this is the moles relationship. We are going to time the moles relationship to the given numbers, which is 2.5 mole of BbI2, lead iodide. So when we time them together, let's cancel the moles of BbI2. So 2.5 times 2 equal 5 moles of potassium iodide, and this is the actual number of moles of potassium iodide. So pause this video and try to solve this question by your own. After pausing the video, let's try to solve the question together. So we have an equation which is for aluminum plus 3 moles of oxygen, they will produce 2 moles of aluminum oxide. So how can we solve this type of question? Let's find together. Calculate the moles of aluminum oxide that has produced from 1.8 moles of aluminum. This is the number of moles from the equation. So 4 moles of aluminum, 3 moles of oxygen, 2 moles of aluminum oxide. So this is the practical number of moles. What is the actual number of moles that will be produced by 1.8 moles of aluminum? So let's do the moles relationship first from the balanced equation. We are talking about aluminum oxide and aluminum. So let's point the moles here. We have 4 and we have 2. So let's write the given number, which is 1.8 moles of aluminum, and let's times it to the moles fraction. So the moles fraction has 2 moles. Let's write the given number of moles of aluminum here down below. So 4 mole of aluminum, so we can cancel them. So what about the moles of aluminum oxide? We have 2 moles of Al2O3. So this is the moles relationship. 4 moles will produce 2. So what if we have 1.8? They will produce how much? So let's time the given number with the moles fraction. So 1.8 times 2 over 4, the answer will be 0.9 moles. So 1.8 moles of aluminum will produce only 0.9 moles of aluminum oxide, and this is the final answer. Thank you for watching the video and see you next video.